This video is about comparison of arithmetic sequence and a geometric sequence. For arithmetic sequence, the definition is the difference of any term and its previous term is a constant. Then the sequence is called arithmetic sequence. This D is a common difference. When you prove whether a sequence is an arithmetic sequence, you got to use this formula to prove. For geometric sequence, the ratio of any term and its previous term in the sequence is a constant. Then the sequence is called the geometric sequence. These are called the common ratio. When you prove whether a sequence is a geometric sequence, you got to use this formula to prove. You can figure out this common difference. Use the second term minus the first term, or you can use the 20 terms minus 19th term. Same thing for the geometric sequence. The common ratio equals u sub 2 over u sub 1 or u sub 20 over u sub 19. The general form for arithmetic sequence is u sub n equals u sub 1 plus n minus 1 times d. For example, I can write down u sub 9 equals u sub 1 plus 8 times d, or u sub 100 equals u sub 1 plus 99 times d. For geometric sequence, u sub n equals u sub 1 times r to the n minus 1th power. For u sub 9, I can write down u sub 1 times r to the 8th power. For u sub 100, I can write down u sub 1 times r to the 99th power. Arithmetic sequence is a linear function with a natural number as a domain. So for this x will be a natural number. Then this will be the arithmetic sequence. For geometric sequence, it's an exponential function with a natural number as a domain. When this x is a natural number, this will be the geometric sequence. The common difference will be the slope. The common ratio will be the base. So for the sigma notation, when you say this linear function, then this will be arithmetic series. The d is the slope. The number of terms will be this q subtract this p plus 1. Don't forget plus 1. From this sigma notation, we know the starting ordinal number is p. How to get the u sub 1? When k equals p, we plug in p for k. We will get m times p plus b. This will be the u sub 1. Then you can use this formula to figure out the summation of this sigma notation. For example, first of all, we know this is a linear function, so it's an arithmetic series. The common difference is a slope 2. Then the number of terms will be 10 minus 4 plus 1 equals 7. And then the first term, the starting ordinal number is 4. So the first term will be 2 times 4 minus 5 equals 3. Then s sub 7, altogether 7 terms, equals 7 over 2, 2 times 3, then plus n minus 1 is 6 times d is 2. 12 plus 6 is 18, so you will get 63. For geometric sequence, sum of a times b to the k's power as k goes from p to q. P is the starting ordinal number. The common ratio will be the base b. Number of the terms will be q minus p plus 1. When k equals a starting ordinal number p, then a times b to the p's power will be the first term. You can use this formula to figure out this sum. Let's go to example. Sum of 3 times 1/2 to the k minus 1's power as k goes from 2 to 5. For this function, 3 times 1/2 to the k minus 1's power is a times b to the x power form. This is a geometric sequence. For this geometric sequence, the common ratio is the base 1 over 2. Number of terms will be 5 minus 2 plus 1 equals 4. The first term will be the starting term of this summation. That is 3 times 1 over 2 to the 2 minus 1's power. That equals 3 over 2. S sub 4 equals, U sub 1 is 3 over 2. 1 minus 1 over 2 to the 4th power over 1 minus 1 over 2. Answer will be 45 over 16. The formula for arithmetic series is this one and this one. There are two formulas for geometric series. You can use either one. You will get the same answer. Let's talk about consecutive arithmetic sequence and consecutive geometric sequence. For ABC, suppose this is a consecutive arithmetic sequence. We do know b minus a equals c minus b. That equals a constant number d. Let's working on b minus a equals c minus b. Add b both sides, we will get the 2b minus a equals c. 2b equals c plus a. This is a very important formula for consecutive arithmetic sequence. If we divide it by 2, we will get the b equals c plus a over 2. This is the second very important formula for consecutive arithmetic sequence. For consecutive geometric sequence, we do know a over b equals c over b equals common ratio r. Cross multiply, b squared equals a times c. This is the first formula for consecutive geometric sequence. If we do square root both sides, b equals plus or minus square root a times c. The second formula for consecutive geometric sequence. When you see the word increased by the same amount or decreased or reduced by the same amount c, then this is an arithmetic sequence and a series. For increase by the same amount c, the common difference equals c. For decrease or reduce by the same amount C, the common difference equals negative C. When you see the following words, it will be geometric sequence and a series. 8% of the previous one. Common ratio equals 8%. C times the previous one. Common ratio equals this C. Increase by 8%. Then common ratio equals 1 plus 8%. Decrease or reduce by 8%. Common ratio R equals 1 minus 8%.